In this video, we're going to evaluate the sum of 16 times minus a half to the power of n between n equals 2 up to n equals 8. Now I'm going to show you two methods for this. Either would be correct and either would get the marks on the exam. One's a little bit faster, but you might prefer to use the second method instead. So the first method is going to start from n equals 2. And let's start substituting this into our expression. So when n is equal to 2, you have minus a half squared, which is a quarter, and a quarter times 16, which is 4. If n equals 3, you've got minus a half cubed, which is minus 1 over 8, times 16, which is then minus 2. If n equals 4, you have minus a half to the power of 4, which is 1 over 16 times 16, which gets you plus 1, and so on. So what we can start to see is between our expressions here, there is a common ratio there, and it's a multiplication of minus a half. You can probably guess that from the expression, but this just confirms it. And if we're multiplying by minus a half each time, that means if we've got a common ratio that this must be a geometric series. So we can actually use our formula for the summation of the first n terms of a geometric series. So to use the formula, we need to list our key values. Well, if a is our first term, we can say that that's 4. We've got our common ratio, which is our multiplying factor, which is minus a half, and then we're looking for our number of terms. Well, if we're starting with 2 and going up to 8, we are looking for 7 terms there. 2, 3, 4, 5, 6, 7, and 8. So we're looking for the sum of the first 7 terms. And then we just need to substitute into the formula. So the sum of the first 7 terms is equal to 4 times 1 minus a half to the power of 7, which is n, over 1 minus a half. 1 minus a half is 3 over 2. 4 divided by 3 over 2 is 8 over 3 times 1 minus a half to the 7, which if you put that into your calculator, you end up with 43 over 16. And that is in fact our solution to this problem, that the sum of 16 times minus a half to the n between n equals 2 up to n equals 8 is equal to 43 over 16. Now, an alternative method, if you want to view this as, well, we start at n equals 2, what about if we start from n equals 1, which would normally be the first term of the sequence? And we can sum up to the 8th term, but if we're going to do that, because we don't really care when n equals 1, we would need to subtract the sum of the first term. And specifically for this one, we're going to have to write out what our terms are again of the sequence. So if n equals 1, minus a half to the power of 1 is minus a half, times 16 is minus 8. Then n equals 2 gets us 4. Then n equals 3 gets us minus 2, then plus 1, and plus so on. Again, we've still got a multiplying factor there of minus a half each time, so times minus a half times minus a half. So we can write out our key points, that this time a is equal to minus 8, r is equal to minus a half, and for this problem we've got to substitute it in twice. So the first one is using n equals 8. So the sum of the first 8 terms is equal to, in fact, minus 8 times 1 minus a half to the 8, all over 1 minus a half. Now the sum of the first term is literally just the first term, which is minus 8. So actually, Well, we can simplify this. 1 minus minus half is 3 over 2. Minus 8 divided by 3 over 2 is minus 16 over 3 times 1 minus a half to the 8, or 16 over 3 times minus a half to the 8 minus 1. So we can substitute in that expression there. 16 over 3 times minus a half to the 8 minus 1 minus our sum of the first term, which is just the first term, minus 8. The minus become a plus. So you get 16 over 3 times minus a half to the 8 minus 1 plus 8, which, if you go to your calculator, will once again get 43 over 16. Now, more often than not, you would generally go with the first way, but the second is perfectly valid and it's just another alternative method if you always prefer to go from the n equals 1 up to whichever term. But you've just got to remember you're going to have to do some more calculations if that's the case.